All right, everyone, welcome to another
9
round.
objections sounds like a lot.
Yeah, so welcome to another round of API reviews. Today we have only 3 issues, and then Tana wants to do some breaking change stuff. So let's see how far we get. I assume nobody has context on this one because it's a WinForms one.
Can you zoom in?
Oh yeah, let me increase the zoom level for people my age group. Where's the... I'm yet to see the API proposal. Is it really? Is that the one?
Looks. Yep.
So it's a new add to recent property in a few places that defaults to true. Or false, depending on.
Yeah, it seems like there's a bunch of properties, right? Add to recent, show hidden files, show pinned places, show preview, select read only. Yeah, I suppose they're just, based on what I scanned earlier, it's like just a bunch of flags that they expose in Win32, but they don't have exposed in the on the wrappers, and the usual pattern for the flags is a bunch of bools. Yeah, I mean, that seems reasonable to me in general. I mean, that's the general pattern that they have, right? They have these default value attributes that effectively controls what the default value is if nothing is specified, and it's used by the designer to determine whether it should be serialized into the, generated, was it component initialize or form initialize method that they generate. So that seems pretty straightforward.
I think the one interesting thing is that on the Win32 side, these are enum flags, whereas on the WinForms side, it's a bunch of bools and properties, and so there's no way to actually modify multiple of these at once. You're going to have to go through multiple sequential steps to do so. But that's also how they're doing it today. Just thought it was maybe interesting.
Yeah, I don't even know how they generate the flags enum. I'm pretty sure they just do it, whenever you effectively do this, the show dialog, then they generate the enum and pass it to the Win32 one. So I don't think there's a continuous update happening when you're setting them.
Well, it's more once it's live, I think. Because you can change some of these once they're live.
I see. But they're all modal dialogues, right? So it's a bit weird to do that once this thing is live.
You'd be surprised what people do in WinForms.
That is definitely true. I've seen
Looks
things.
like they. It looks like they do actually have it. You can set them all at once via protected options field.
God, why did I just launch Visual Studio? That was not my plan. But now I have 30 seconds to thoroughly regret my choice. All right. So that's one thing. Then this was the other one. And then this one here. I mean, does anybody object to any of those? I mean, it's just a bunch of common dialogues, right? The pattern is pretty much the same. Given that the WinForms guys are happy with it. I think the question is just whether we are happy with it. But I don't see any reason why we wouldn't. The only question I have is, I believe we have some of these duplicated, don't we? Didn't we have like we have open file? I thought WPF has their own version of those. Is that not true?
I think they do, but I don't remember how it's exposed.
I also don't remember what our decision was. At some point I brought it up with them and said, like, do we want to do this coevolution in both places, or do we want to designate one as the true source? And I don't think we ever resolved that.
I think with how they're layered, it's duplicated today, and I don't think there's a good way to allow them to be shared.
Yeah, I think and we looked into this, the reality was that WPF already has a WinForms dependency somewhere, on the implementation side at least. But yeah, I don't think I can see what the dialogues are. Are they in shell maybe?
Right. So WPF allows you to get the underlying handle, and then you can do interop with WinForms, and then WinForms can also do like WPF hosting, and it's all just Win32 under the covers, so you can do all of the interactions you might want. But I don't think you get system Windows forms or anything like that in your output today if you just build a raw WPF app.
Interesting.
Looks like Microsoft Win32 open file dialog for WPF.
So what was the name?
Microsoft.win32.openfile dialog.
Okay, that would have not be.
Or because to get access to the system level one, it's different from the other one.
Right, that is WPF one for sure. I don't think we have a confidence how to derive types. That would be. Yeah, it looks like WPF only has open file and save file. Which makes sense. I think they don't like. I think WinForms always had more fidelity there, but all right. Any other questions? Otherwise, I'm quite happy to approve it as proposed.
If they already have a pattern of having things default to true, then it all seems fine to me.
Yeah, I believe they do.
Yeah, they match what the underlying dialog does by default, if I remember correctly. So whatever Win32 APIs do is what they default to as well.
Right, but I assume that what Win32 actually has is the bit represents, if you assert the bit, it suppresses something instead of for the ones that they're defaulting to true. So it's Win32 probably has negative logic, and so it's a question of if the thing's defaulting to true is a pattern that they've already done and it already works in all of their contexts, then it's great. But if they ended up with, just calect structures, then you're not going to get the behavior that it looks like you were getting. Which is why it's, as long as this is a pattern they've done before and they know it works, then it's good.
Yeah, I think the idea here is just the true and false is just basically what is serialized, right?
Yeah.
So it doesn't really matter what the underlying OS's defaults are. It's just that that's what they happen to decide to be the default.
It's fair. I'm just guessing that anything that they're defaulting to true, if you look at the Win32 documentation, it will be like no something. And so that they're describing it always in terms of positive behavior instead of suppressed behaviors.
Yeah, I would assume that Win32 only has a default for the entire set of options rather than specific options, right? So if we don't specify the flags at all, then, well, by default, these 5 flags are specified basically, right?
I mean, I assume the default's 0, and then you get like,
oh yeah, fair enough.
Right.
Like, WinForms _ no add to recent is the name of bit 17.
Right.
Like show pin places is hide pin places in the FOS enum, for example. But this is very consistent with what they have in the rest of these classes.
Yeah, I mean, we generally prefer like positive bools, right, rather than negative bools, because then you have to do this math in your head what setting it to false now means.
Yep.
All right, then take this as a given, and then all right. Anybody have context on this one? Who marked it ready for review? Joe did.
Do we have filter and we're adding escape, or are we adding a filter?
I think we're adding the class to hold the static. Because I mean the filter itself is just a string, I believe. I don't think LDAP filter exists today. It does not. Oh yeah, that's a happy namespace with only a few types in it.
Mm-hmm.
I mean, we can probably put it anywhere we want. But quite frankly, adding a new type also would not be the worst in the world given this namespace here.
What are you talking about? That's pristine.
Yeah, I mean, I looked at LDAP like 15 years ago, and I don't remember anything, so
my only question, without knowing anything about any of those 40,000 types you just scrolled through, is do we really need another type, or is there not one of them that this could be added to?
Yeah, that's kind of what I was hinting at. Like, I mean, I know enough to actually know where this logically belongs. Like, my only recollection of this namespace is that it basically does both, right? It does the, because basically, my understanding is that Active Directory is kind of an implementation of LDAP. And so some things here are specific to our, you know, basically AD, and some things are just generic LDAP things, right? And so there is not really a super clear-cut line. So I don't know where this filter thing would fit in, for example. And maybe it doesn't matter, right? Because, I mean, some of this stuff is like, who cares what the spec says? But I assume it's a generic LDAP concept where you can escape.
Maybe like it because it seemed based on their words, they're escaping things for the basically the search syntax, which it calls filter. So there is Directory Services Protocol's search request, which has a filter property. So presumably this is for building things on said search request.filter. So if we wanted to avoid adding a new type, search request.escape filter string is near where you would use it. I don't know that makes it entirely discoverable, but it's near where you would use it.
I mean, that wouldn't be bad. I mean, statics are generally unfortunate, but that's, you know, you pick the closest type, right?
Yeah, it's the best. I think that search request there's probably the only thing that needs it. So that's probably the place to put it. And if Joe disagrees, he can always bounce it back to us.
I am not entirely sure what format is supposed to do, though.
No, I don't think that made it into the final proposal.
Yeah, Joe is asking whether we should put an LDAP connection. Which I think the assumption is that that's the number one type you, or the first type you have to do anything with to, so you clearly know that type. I'm not sure that's the logical home for that, because I kind of agree with you. It seems if the filter only exists in search request, then, you know, that seems like the better home, but I am not an LDAP expert, so, but that might be the questions we should ask, right? So if we just take the proposal from here.
Steve, have you seen anyone using an interpolation handler to try and do escaping, like URL composition with applying the escaping rules to each parameter?
I haven't, but it's pretty new, so I think we haven't yet scratched the surface of what people are going to do with those.
Fair. I'm just looking at his API usage line right here and was like, I wonder where in here there was the expectation of substitution, but or of escaping. But I guess yeah, it's actually written in explicitly.
Yeah, I mean, if someone was doing this as a handler, they would have, you know, a method that accepted a handler, and then anyone using an interpolated string, some subset of the arguments would be automatically escaped, as it were. often with escaping, I'm not sure how well that would line up in general in situations where you didn't want to escape everything. For situations where you literally wanted to escape every hole always, I would not be surprised if we see that start to.
Yeah, it was like a URL builder. If you drop the host in, that would have different syntax than any of the query parameters.
Right.
And so you'd basically end up inventing your own format string language to have to handle it, at which point it probably wasn't worth it.
Right.
So I was typing. What did you did you suggest that we have a builder pattern for this whole thing rather than?
Oh no, I simply thought, based on looking at their example here, which used a $sign string, that possibly the thing with format is that they were trying to make this be automatic escaping based off of a interpolated string handler.
I see.
So I was slightly brainstorming that concept while convincing myself it's a bad idea.
But I mean,
So just do your normal thing and ignore me.
I mean, it's an interesting question though, like whether, you know,
I mean, certainly a builder for this is not entirely useless. It's just weird in the way that it.
Sorry, folks, just joined, and now you're talking about this one. Sorry about that. I was in tactics.
no worries.
So I don't know how far you've discussed this one, or do you want me to?
I think we have a rough idea of what it is. So basically, what we're discussing is basically, do we need a new type, because that's the proposal here, LDAP filter. But you already proposed, I think, LDAP connection. We were just looking at the namespace and thought maybe search request seems maybe the more logical home, because it seems you're constructing a filter, and search request is presumably one of the few places where you can plug one in.
Right. The only other thing is, like, for example, there's also like add requests and things like that. And you can presumably think of, like, what if they're trying to add a user that has one of these things that need to be escaped. So that's why we didn't limit it. Well, when I proposed it, I didn't limit it only to search request, and said maybe LDAP connection is a more natural place, because like all of these types of requests, you send them through the LDAP connection.
Right.
So that's kind of why I thought that maybe LDAP connection might be better.
But are they the same kind of escaping?
They are, yes. I believe they are.
Because this one's specifically proposed as escape filter argument, and there's no filter on the add request. So if it's just for the filter, which is the search syntax.
Right. I'm pretty sure the answer is yes, but I can double check and make sure about that. So yeah, I know that it doesn't. So add request doesn't take a filter, but it takes in the whatever the name of the object is that you want to add into the directory, and so that thing can contain some of these characters. So the idea is you might need to escape those in order to send them over the wire, just because LDAP in general treats them special. So yes, I like it is particularly special when you're searching because of the syntax of search. But then I believe that there are some other characters in here that might need escaping as well. Yeah.
Right. Because if it's the same escaping syntax used for escaping RDNs and filters, then something like LDAP connection dot escape LDAP value or something seems reasonable. If you're adding an escape, you might also need the unescape. Granted, there's not a real need here because you're going to build it, send it to LDAP, and it's going to give you an answer. But
right.
Like if you get back an RDN that had an escaped value, is it already processed by the system today?
It is.
Meaning you also have problems of if you get a special RDN and you just say, add RDN into directory 2, the answer from directory 1, now you have an escaping problem.
Yes. You would have to escape the answer back.
That seems like
I don't think that's
some sad
super
state
common.
that we would need to deal with. Well, but something like the RDN, we'd know that there's not a composition problem, so we should handle the escaping for you. It's only the filter that we don't understand if the parenthesis was you were adding another group operation, if you were actually trying to make it part of your string.
Right.
And so now we come back to if something like the add request should just escape the distinguished name for you, then the only time anyone would call this in public API would be for filters. And so maybe it's fine to call it search request dot.
Makes sense. I think you're making me question myself. I'm pretty sure that I saw escaping on add request as well. But I haven't looked at that code for a long time, so I can try that again. Make sure that it is the right like if I see that add connection might also need escaping, then yeah, search LDAP connection would be the right place, I think. If not, then I'm fine with having it in search request. I think that's fine.
Right, but I think if it goes to LDAP request, it needs a different name because it says right now it's escape filter string, and if you're doing a code review and you see that you're assigning add request distinguished name includes escape filter request, it's like, well, you're using the wrong escape.
Right.
So.
Yeah, makes sense.
God, what did I just do?
So maybe just escape. That's what we have in regex, for example.
Maybe.
I mean, if the concept is generic, I would go with something simple like escape. If it is very specific, then you need to be very specific in the method name. But that kind of depends, I think, on what the thing is for. So my other question is, like, is the vector services protocols generic LDAP, or is anything here specific? Like, is this one of those namespaces where you have overlap between AD and LDAP in general?
This is the one. So we have 3 different implementations of some sort of LDAP, 3 different namespaces. This is the one that is generic. So protocols is the one that is not tied to AD. The other 2 kind of are.
So then everything in this namespace is basically LDAP.
Correct.
So then I guess it doesn't really make a difference whether we prefix it with LDAP or not.
Right.
So a search request is an LDAP search request already. So there's really no point.
Yes. Yeah. That is correct. So you're saying like maybe LDAP, like if we were to go with LDAP filter, then the name LDAP becomes kind of like redundant. Is that what you're saying?
Yeah, basically. I mean, yeah. If the only option is called filter, then you need to probably prefix it with something. Otherwise, it's weird because this is not the one type to escape all filtering, right? It's just the LDAP filter. But yeah, it seems a bit weird that we have LDAP connection and directory connection. So it's a bit of a weird setup.
Yeah. Directory connection, I think, is just the abstract class, right? That LDAP connection.
Yeah. I mean, I don't know. I didn't design namespace, but I would have said like come up with one term, right? Like either use LDAP consistently or use directory as the thing, right? But
well, yeah. I mean, I don't know if this was actually trying to do the L in LDAP is lightweight, which presumes that there's also DAP, the directory access protocol, and
I see.
So like Active Directory, the directory word comes from the the X500 specs. Like that, we didn't make up the phrase Active Directory. Active Directory was just our particular implementation of the directory.
Right. Yeah, I mean, maybe there is no one, DAP, right? It's like XML, right? What is the non-extensible markup language, right? But yeah.
In any case, I don't think the LDAP filter will probably be the right place. So as we said, it's probably either search request or LDAP connection.
Yeah.
So yeah.
Are there any other? I mean, the only thing you should probably look at is if you put it on the connection, given that there is a hierarchy, make sure that makes sense to people because you generally don't call statics to derived types. Or can you? I think you can.
Same.
I think you can. You just get a squiggle in the ID that
says...
Yeah,
you can. I wish you couldn't.
But that solves that problem, right? So if we put it on the connection, we should probably put it on whatever the base type is.
Well, again, that depends. Assume that there is LDAP and DAP. if the escaping syntax is specific to LDAP, then we shouldn't put it on DAP. Or we shouldn't put it on the base class.
Right. Yes. But yeah. But you get my point, right? It would be weird to say you're using this thing and then the escaping, which applies to you, is on this other type. Because then you just increase the concept count for that scenario.
Yeah.
For what it's worth, I don't have telemetry on this, but I haven't seen any case out in the wild that uses directory connection. Everybody that I've seen in the world uses LDAP connection.
It seems the only other derived type is DSML SOAP connection, which I don't even know what this means.
I can fill in letters, directory service markup language.
It enables stateless and stateful protocols to be handled similarly by providing session-oriented features. I would venture a guess and say it still uses the same escaping. So we should probably put it on the base, I guess.
Okay.
So,
yeah. As for a builder for the filter things, it's probably useful, but I think it'll end up being like Azure query builders, that it's like the builder is actually just hurting me. Because there's not a good way for it to be able to express the hierarchy of things unless you build it as a graph of operations, which would make Steve cry with the amount of discontiguous memory it took to build a string. So I think it's an interesting thought concept. I just don't know how it can easily work in practice, given that it's a prefix Boolean conjunction.
yeah, I mean, the way you would do it in a builder is probably have a method that's like, start parentheses that gives you back an idisposable, or just in that concept somehow, right, to do nesting.
Yeah.
But yeah.
Usually all of the people that uses LDAP connection, because it's such a low level type, they're very, very familiar with the LDAP query syntax.
Yeah, I expect it's similar to SQL, right? People don't really use builders to create a SQL query, right? They do it for the connection string because it's relatively simple and you really just want the strong typing for the keys, right? But then for the actual SQL query, it's like, yep, here's a bunch of text I came up with somehow.
Yep.
Right.
And so that might be similar here. But then we also know that, there are holes in that thing. And then as soon as you start building things there, you basically open up yourself for misuse, right?
Mm-hmm.
Anyway. Presumably LDAP has no concept of property of parameters, right?
Nope.
Yeah.
Not that I'm aware of.
Then I guess we put this back with needs work then, based on.
Good.
Right.
Yep. Yeah, I'll make sure. Do we have to bring it back? So once I figure out if it's in search request or LDAP connection, do you want us to bring it back to discuss, or?
I mean, usually yes, because by the time you come back, you change something. You probably change the naming or something. Like, I mean, was it really just this type or that type? Then I wouldn't bother.
Yeah, I think if it goes as search request escape filter argument, that's probably just send the email that no one will ever reply to. If it's anything else, then now we'll have to talk about the suitability of the name.
Makes sense. Okay, thank you.
Inline array attribute. I think Tanner had context in this one, right?
Yeah, I've got context. So basically, today we have fixed size buffers that you can declare in C# using the fixed keyword, but it's limited to effectively just the primitive types. This is a proposed attribute, and there's actually a number of issues that can arise from the way C# handles fixed size buffers and other things today. the proposal is to expose a new attribute, inline array attribute, in compiler services that allows us to basically declare a struct with a single field with this attribute that specifies how many elements should actually exist. The runtime will then specialize it, as will all other places that need to understand that this is an inline buffer rather than something else. So likely the debugger and other things would also understand that there's actually, length fields rather than just one element. And that's basically it.
Didn't we have this concept in marshalling already, where you have a marshal attribute on it that says this is inline data or something? Or is this...
That doesn't work for managed code. This needs to work so we can declare structs and do value arrays and other concepts in like having spans of reference types. So you can do param span for object, for example.
I see. So marshalling would only kick in when you send it basically to the p invoke boundary. This one is actually saying I want the CLR to lay out this memory differently.
Right. And so it actually works for managed code as well. It will work when the user decides to do like runtime compat, disabling the marshaller with the runtime compat attribute we approved last week, etc.
And so presumably a user needs to manually apply that attribute though, right?
I believe C# will automatically emit it in the appropriate cases when it extends the fixed size buffer support, and otherwise users could indeed declare their own and apply the attribute themselves.
Sorry, I think I missed the part. So what is the C# syntax for that?
It would still be fixed, but would be on types that fixed doesn't currently support today. So like if you did a fixed size buffer of GUID or of strings or anything like that, then
so where does the fixed keyword go? Like, isn't fixed something that you do inside of a... That's what you do normally in statements, right?
No, there's also public fixed float x, and then open square bracket 5 close square bracket.
I've never seen that. Okay.
It's unsafe only today.
Interesting. I see. Gotcha. Yeah, that would make sense. Yeah, so the only reason I said it is like if we expect people to manually apply it, then compiler services would be an unfortunate choice. If we expect the compiler to emit this attribute based on some other language syntax, then that is the exact home where it should go.
Yeah, this is primarily a language feature thing rather than a interop thing. It happens to be that interop users will also care about it, but they probably won't be declaring or using it manually. They'll be using the language syntax.
Yeah.
Outside of very specialized scenarios like variable length arrays and things like that.
So what does length actually indicate?
The number of elements of type T that will exist in that the VM will cause to exist in the struct. So in the case of my array of T here, the VM will see this attribute, and it will basically dynamically change the layout of the type from a single T to have 42 T's instead.
So does it only apply to generic structs then? And it's always...
No, it applies to any struct that contains a single element of any type. So you could declare this as struct.
Gotcha.
My float fixed size buffer, and then you could just have a single float field in it with whatever length you need.
I think length is a bit weird in this context. But maybe that's just me, because to me length I don't know, maybe I'm thinking this the wrong way, but to me, like, it sounds more like count, but I guess length and count, if you look at arrays, is the same thing, but
Right.
yeah, I guess, yeah.
The primary difference is we use count in growable structures, and we
That's
use
fair.
length and span in array.
Because when I saw this, I thought this means length in bytes, but it's really a number, like, basically, yeah, the number of logical repetitions.
Mhm.
But I guess that's how arrays work today. So yeah, I guess length is fine after all.
So if you have, anytime you have a different length that you need in a nested struct, you need a different type to encapsulate that data.
If you don't declare a generic so you either have to have a struct per length or a struct per type. And the most appropriate scenario is generally a one per length that you need to support, and there's likely not going to be that many. The main need for this is if you have to manually declare 42 elements in your array or in your struct, then you're adding a lot of metadata bloat that can't be trimmed, and that causes potential other issues.
So there's some discussion in chat around the refness. I guess that's just an example, right? As you said, there's nothing specific to span here, just the usage example, right?
Right. The language, in order for span to be exposed and for it to be safe, the language will have to finish implementing the low-level struct improvements that allow it to properly track lifetimes for struct fields returned by ref.
Right, and so like the code as it is on the screen right now is presumably will compile, but
yeah, it will
not
compile.
safe.
It's just unsafe because if you declared the myArray in a method, then the language would allow you to return the span, and so the language needs to implement the appropriate stuff, which is, as far as I'm aware, still on schedule for the next release.
Yeah, that makes sense. I mean, everything memory marshal today is kind of, know what you're doing or bad things will happen.
Yeah, but right now this is, if you say, my array of t or my array of int foo equal default that slice example, you now have a span of int that is going probably through your stack cookie.
I mean, the one question is, that sounds to me like it needs to be on the runtime feature side, because if I take this code today, put it in, the compiler, it will compile just fine. It's just that runtime won't honor the attribute, and your code will explode at runtime in spectacular fashion, right?
The existence of the attribute is the implication that the runtime supports the feature. It's not going to exist on down level platforms.
I guess that's fair.
Okay, so this will be the first attribute-based feature we've added in a while that is not duck typed.
Well, I mean, it's different, right? Because it's not a compiler attribute, right? This is actually a runtime attribute that the compiler just matches, right?
That's fair.
So runtimes that don't support the attribute should not have that attribute, basically.
Yep. And that's the general split that we have. Runtime compat flags are for runtime features that the language depends on when there's no alternative type that it can rely on to determine that a feature exists. Like we don't have a compat flag for a few I think it's function pointer related features, because we just rely on the relevant attributes existing instead, or types. Whereas the duck typed attributes are for things that are language side only, things that the runtime has no understanding of.
Because I just feel like most of the things so to Levi's earlier question of should this be in compiler services or interop services, I feel like most of the things in compiler services are duck typed. If I'm mistaken, that's fine. But that if this actually changes the runtime, interop services feels more natural to me.
Sorry, could you repeat that?
My gut feeling is that most of the things that we've added recently to compiler services are duck typed, and then perhaps most of the things we've added to interop services are not duck typed. So if this is not duck typed, it feels like interop services more than compiler services.
There's a mix of them in each. This is explicitly not an interop related feature. It is a runtime and manage side feature that happens to be usable in interop related code. But the primary use of this is going to be in things like params span and manage side features that the libraries are going to expose.
Yeah, when you say duck typing, the problem with duck typing is realistically, this is only when you look at the compiler, right? Is the question is, will the compiler bind to any attribute with that name regardless of location, right? Versus if the attribute is interpreted by the runtime, we don't really have that concept today outside of very targeted areas, right? I mean, some of the JIT stuff was in that bucket where, well, we only compare some strings, and so we don't really care what location the thing is in, right? But by and large, like the things in runtime interop services are not duck typed by the runtime, but they either are on it or they are not. And some of them are not even expressed metadata, right? Some of them are just, a convoluted way to specify bits in the underlying metadata format. Like the DLL import attribute, for example. Well, there clearly is no duck typing. So, I mean, to me, it's more like, is the user using the thing directly in code, right? And normally compiler services is for stuff that the compiler emits, but the user doesn't have to hide it using for and has to fish out types, right? We have messed this up in a few areas, but we tend to avoid that because the namespace is a cluster of a lot of stuff.
That's fair.
So then we are basically with this, right? Let me fix some typos.
I guess we're lucky we think that we're done updating .NET Standard, because otherwise we wouldn't be able to adhere to that first bullet point.
Why do you think that?
Because we'd have to decide, does .NET Standard allow you to declare this or not? And then that would be a question of, does that mean in order to move forward on further .NET standards, you have to support this feature, as opposed to it being an optional runtime feature, but we still need the attribute to be present in the compile target.
Well, in that case, you would, I mean, that is similar to the runtime feature thing, right? Where we would say, but basically we have to decide, do we put in the attribute or do we put in the runtime feature field? But that's more or less the same decision, right? Now, in order to move forward to a new version, you have to support that feature.
And I guess it's true anyway. You'd have to say, for whatever universe you're in, that you are now saying you're depending on a runtime that has this feature. Otherwise, whatever is supposed to come out the other side wouldn't make any sense. So.
Yeah, so I would think that, it would probably make it mandatory, would be my guess. Because we know the runtimes, right? So
that's effectively what we're doing by not having .NET Standard anymore. The latest release of .NET is the newest standard, and in order to support it, you have to require that stuff.
Yeah, and we're basically owning both sides of the runtime, right? Because there's only two moving forward, and so, I mean, 3 if you really squint, but. I guess that doesn't really count. Yeah, I guess the question in chat is, how does it point to local memory? The answer is it doesn't. That's part of the feature work that Tanner was referring to, that the compiler has to track this better. But that's independent of this attribute. That's just when you involve span. The attribute is really just about the runtime lays out the thing in a certain way. And
then there'll be language syntax that will take advantage of it and do the appropriate, relevant, and correct things.
So the only question I have is like, I'm fine with approving it. I mean, the only thing is like, is there any pending work on the on the compiler side where they may come back and say, oh, this shape doesn't work for us?
Not that I'm aware of.
So if that's the case, then we can approve it, and if they don't like it, we can come back. And then that is that. What is your breaking change thing?
61885.
6-1?
Yep. 885.
885.
So an issue we've had in .NET for a while is that there are certain behaviors that are effectively implementation defined, because there is no defined behavior from either in the runtime spec or elsewhere. One of these examples is floating point to integer conversions in the case of overflow, or where the value can't be represented, such as nan or infinity. This leads to numerous issues in various places today because the platform behavior between x86 and ARM is different, for example. And so on ARM, they actually have the behavior of they saturate results by default. So if you try and convert, 18 quadrillion into an int32, it just becomes int32.maxValue. Whereas on x86, if you do the same, it returns a sentinel value. It returns int.minValue in any overflow case. And so this leads to issues where users can't rely on deterministic behavior across platforms, where you can't do where you can't actually do certain types of constant folding reliably in various cases, etc. And the compiler, the C# compiler, actually had to normalize this because they aren't doing things for a particular platform. They're compiling down to IL, and they normalized on just defaulting to 0 for all of these cases. The proposal here is that we update .NET to have a consistent behavior for floating point to integer conversions on all platforms. That the C# compiler be updated to conform to that to that behavior, and that become the standard moving forward. There have notably been other languages such as Rust that have also done the investigation here and determined it to be worthwhile overall. And in particular, we'd normalize on the same behavior as ARM, 64, Rust, WASM, and other modern platforms, which is we'd saturate the result in all cases. Notably, that will cause a perf regression on x64 for some cases. The worst case scenario that Rust observed was about a 0.8 times regression, so about 20% slower-ish in an RGB JPEG encoding algorithm. Rust works around this by exposing some additional APIs that allow you to get the platform-specific behavior. And I proposed we go ahead and, as part of this, expose additional APIs on double, single, half, and the corresponding vector types to allow platform-specific behavior as well. And the proposal for that was to call them convert to int32 unsafe. Unsafe being the moniker we've used in the hardware intrinsics already to represent non-deterministic or platform-specific behavior. There's some people who suggested we use a word other than unsafe. I don't have a particular preference there on if we called it native or something else. Unsafe just happened to be the thing we were already using to represent non-deterministic behavior elsewhere.
So I understand the need then for the unsafe variants, but why would we also add the non-unsafe ones? Why are the existing convert to XXX not good enough?
So on vector 64 and vector 128, for numerous reasons, we have APIs called convert to int32 rather than allowing it via an explicit casting, because the explicit cast means something different. And so on the vector types, there will be convert to int32 and convert to int32 unsafe, or whatever name we determine. And so for double, single, and half, these would exist for parity, just for parity between all the types. That way, regardless of whether you're looking at the scalar type or the vector type, you see the same set of APIs available there.
So what does the existing convert dot to int32 then do when you pass in a double? It would follow the changes and do the non-platform specific conversion then, right?
Right. It would do the saturating behavior on all platforms.
Because the proposal is basically to bake it both into the compiler and I suppose into the BCL, right?
Correct.
And so then the only ones that would use the platform specific ones would be effectively the unsafe versions, right?
Right. The unsafe would represent, I do the platform specific behavior. That's effectively whatever is fast. And so for x86, this would return a sentinel value. Byte, sbyte, short, and ushort are explicitly not covered because there is no platform specific conversion API. And so it's not worth exposing an API that is both slow and consistent with what int32 and int64 does. So for byte, you'd convert to int32 and then downcast again to byte, giving you platform specific and then truncating behavior.
I see.
Yeah, and to answer Levi's question of why not under the intrinsics, we technically have platform-specific intrinsic APIs today. However, for many reasons, including why we're exposing, for example, the cross-platform vector helper APIs, it's problematic for users who want to support platform-specific behavior to have to go and do, if x86, then create a vector and then downcast and then extract the scalar for x86, x64, then also for ARM32, ARM64, and potentially other platforms as well, like WASM in the future. And so putting them on double gives you a very explicit way to get the platform specific behavior on the type that you care about it for.
So I guess one question I have is, like, I think in chat that's kind of similar. So how does it compose with our static abstracts and interfaces? Like, do we need basically an interface representation for those things, or do we not?
Yeah, I would likely be covering that under the binary floating point interface with whatever name we determine. We'd review that independently when we next look at the .NET 7 proposed changes for the generic math stuff.
Yeah, I was kind of like, up until that question, I was more in the camp of like, it makes sense for the vector types to follow that pattern, but then it would make more sense to follow the convert dot pattern for the primitives. But given that we probably need statics for the interfaces anyway to work, we might as well just plumb this thing all the way down and have it the same everywhere. What do other people think? Hey, only one at a time, please.
Personally, I question the need for the unsafe ones to be as exposed as they are.
There's going so the reason that I'm making them this exposed is, one, other platforms like Rust have already determined that they are required in some cases. Likewise, for people who are going to be working with these types and who are going to hit it, like I imagine apps like ImageSharp are going to hit this because they're doing things like RGB JPEG encoding. They're going to want to have these in a clear and obvious place. We already have unsafe APIs on primitive types. Like you can create a string from from pointers. You can convert an int32 to a float, and it can cause you to lose precision from the original input because not all int32s are representable by float. I think exposing a couple more APIs to cover the clear and obvious case of I want the platform specific behavior when I'm converting a floating point type to an integer type is.
It's right, but this is take someone new to the platform, right? And fine, you see they've somehow learned that there's a difference between doing a cast of a double to an int32 and that they should use double.convert to int32. Now giving them convert to int32 and convert to int32 unsafe on the same type or whatever suffix we use, like that's just unnecessary cognitive overload on somebody who's junior and somebody who really cares about the perf difference between the two. They will look for the right answer. So we don't need to make it discoverable. Making it exist, sure. Discoverable, I don't care. Bury it.
It needs to be accessible for generic math as well, like Mo mentioned, and so we're going to have something on these types anyways.
But we could do this explicit, correct? So we could hide them if we wanted to, right?
Yeah, we could hide them, but then when it gets down to it, there's not much point in hiding something from here and forcing people to go through a generic math context when they're going to see it from the generic math context anyways, especially when we want beginners to learn about generic math and be able to use it in contexts. Like floating point is already complicated, and the explicit, parenthesis cast int and convert to int32 are going to do the same thing. There's then just the unsafe variant, which has unsafe in its name and is going to push people away, except for those that care about it. And so I don't think it's an issue that it's on the type. No more so than us moving all of the math APIs onto double, half, and single moving forward, or having concepts like infinity nan or -0 there, or anything else.
Yeah, I guess I can buy the generic argument. Really, I'd rather that they were on some other type elsewhere, but if it's something that feels like it's supposed to be an important part of being a binary represented floating point number, then
I mean, I would say, like,
sure.
I have actually a fairly hard time putting myself in somebody's shoes who's learning .NET right now, because I did this 20 years ago, so I take certain things for granted. So I would say convert dot, and then of course you find everything you want to convert, right? So that makes sense to people like me. But if you're a beginner, would that be the place you would look, or would you do double dot? And I honestly don't know, but if the thing exists in two places, which we have in various other instances, maybe that's good enough, because you see convert to int32 seems like what you want, you use it, it works fine. No, and then the only question is now what happens when you see both convert to int32 and convert to int32 unsafe. But I don't know, to me the name would imply that's probably not what I want. So I would probably use the other one.
Well, I mean, if we didn't already have statics on double, then sure, but like a junior, a very new person to the platform, they're going to run across something like double.parse. And so when they go to and they hit double and then they type dot, depending on which version of IntelliSense they're seeing on what and whether or not it's raining outside, convert's going to be at the top, right?
Right.
So
But-
these are now basically the first two things someone's going to see.
I don't think that's a reason, honestly. So for the longest time, we had things like the math class and the separate convert API. And in my opinion, those are bad design decisions from .NET 1.0 because because for whatever reason we decided that the primitive type should be different from every other type we expose in the universe. If you look at any type that's not a primitive type, you don't have things like math. You can't extend it yourself. You can't add APIs to it yourself. So the logical thing to do is to expose those APIs as static members on the type itself. And so when you look at complex, big integer, the vector types, GUID, date time, basically the rest of the world, every static member, whether it's convert APIs, whether it's operators, whether it's helper things like square root or POW, they're all on the type that they're involved with. And so the logical place for things like convert and square root and POW and everything else is on double, half, and single.
Yeah, and I guess if we've already moved over all the stuff off of math, or we're already planning on it, then things like ATAN will actually be the first things they see. So
yeah. I mean, I will say, I agree with Tanner on one side. It's like when you look back at .NET V1, my impression, I mean, I wasn't around obviously, but based on what I read and what people told me is that a lot of the design decisions were basically influenced by what feels heavyweight on the primitives, right? They tried to really create this, notion that they are lightweight types. So they avoided a bunch of instance methods or statics on them. At the same time, like convert was largely seen as a VBism because that was basically required to support some of the VB infrastructure. That's also where iConvertible came in, and that tied every primitive type to every other primitive type. And that was seen as technologically unfortunate. Now, what I don't know is basically what does it mean for usability, right? Because the thing in V1, we didn't really do usability studies that much. So I don't think we ever compared it. But we know that, people were successful enough that we never fixed it, right? So it can't be, like the existing system couldn't have been that bad. I guess math and convert were easy enough concepts to get you, into your head to be successful. I mean, Chet is asking one question, which is, where's convert to half unsafe, convert to double unsafe, and all the other types? So that's, I think, where the complexity may come in.
Yeah. So converting between double, half, and single, converting from them to each other, or converting from an integer type to them is safe. The behavior is well defined by the IEEE spec. There is one answer for all input. There is no implementation defined behavior. It is only for converting from a floating point type to an integer that it becomes problematic.
Right, but I think so I understand that. It's just that the decision on where to expose stuff is now a function of more complexity, right? Because you have to understand what, basically nuance, right? So if I just want to convert stuff, it makes sense to say double dot convert, and then I find 2 and 32, that's fine. Later I need to convert a double to a single, and now I can't find that method. So the question is, are we ending, like, is this basically establishing a pattern where eventually we, for consistency, quote unquote, we now add a bunch of methods onto double and half, right? And so that's I think the question where I don't have a good answer on.
Yeah, I don't believe so. We're only doing it here because this is implementation defined behavior.
Right.
None of the other conversions have implementation defined behavior, and so there's no need to expose them. And if it weren't for the fact that the vector types themselves expose convert to int32, and then we'll have the other name, then I don't think I'd say that these ones should have the non-unsafe versions either. It just becomes a consistency thing at that point.
Yeah, I mean, I think the problem exists regardless, right? So if you strip the non-unsafe versions, so we only have the unsafe ones now. If somebody finds them, well, the obvious question is where are the safe ones? If we only have the ones that have unsafe, versions, then the question is where are the ones that are safe all the way down, right? So either way, it seems like we are in this halfway pregnant state with this design, which is unfortunate, but I don't have a better alternative. I mean, the only alternative I can think of is basically not having them on these types at all and just introduce either a new type or choose an existing type if you have, you know, literally like things like double convert to in32 unsafe. And then say, yep, this is the super advanced scenarios. If you care about those, that's what you would do. But then if we do that, then my question is, okay, well, how do I do this generically now? And so the answer for that might be, okay, in order to make that work, we still have to have those methods on the primitives. We just expose them as explicitly implemented, so you can't see them by default, right? But then I'm not sure we make the world a better place by doing that. But then I guess the question is, do we ever have the need to do generic conversions via an interface at all? Because if we do, then presumably we have the same problem there as well.
Yeah, it's going to be that binary floating point needs a way to expose. I'm going to convert to an integer as the .NET defined behavior, kind of like equals dot equals is always the .NET defined behavior, and has relations to hash code versus do I want to convert to an integer as the platform specific behavior, as in I want to do what operator equals does, which is do whatever the spec says is correct here, or whatever's efficient. And that's basically the two concepts here. Convert to int32 is going to be the .NET behavior, and convert to int32 unsafe is the platform specific behavior.
So what's the feeling in the room? And I use room very loosely here.
If this were 2 years ago and we had, you know, absolutely no inkling of having statics and interfaces and therefore generic math, then I would be 100% behind the kind of thing that Levi wrote in chat. I was thinking something like bit operations. He wrote system numerics platform native. But yes, I think that we would make a side type just for here are your, you know, one instruction, you get what you get, answers, caller beware. If we need it on the generic math, then I think that we have to. I don't think that we could approve the API today because I think everybody should probably think about whether we're happy with the unsafe suffix here or we need a different thing. But as far as the meta shape, I think if there's a feeling that it's required on the generic math interface for this, then we don't have a choice.
I may have missed where it was discussed, but was there a justification for why it 100% has to be in the generic APIs? Like, is this so special case that someone could do type checks and, you know, call the functionality as needed if they really, really needed this in the generic context? It's
a more general issue than just float, half, and double. It's a case of I have an IEEE floating point type of any size, including future expansions like quad or or larger types, and I need to have a fast behavior because performance matters, and I'm doing something like I'm supporting both float and double in my graphics APIs, or I want the deterministic behavior and I want it to be I want a consistent result on all platforms because consistency is important.
I understand all that, but you know, for someone, correct me if I'm wrong, this is a relatively niche case that someone will want, like that someone will be using the unsafe APIs. It is not the common case, or is that just not a true statement?
For the majority of .NET apps, yes. For the areas that care about perf and will also be using generic math in cases, there's likely a much larger overlap things like image processing, machine learning, and others will need the perf in a number of scenarios, and they'll know that none of their inputs are going to be a case where the overflow behavior is even a consideration, and so they'll need to avoid doing things like calling min and max before doing the conversion, or having additional branches in their hot loop to do the check. It's the whole reason why Rust went and exposed these, because there were core workloads where this was causing problematic behavior.
So you mentioned future expansion to things like quad. Doing something like this and saying it belongs on the interface, where until/unless we start having different extensibility models or evolution models for interfaces, this is boxing out longer, or whatever we would call it, into 128. So, I mean, you're talking, it's generic because of extensibility on the one hand, but because of our definition of interfaces, it's not extensible on the other dimension. So does that feel wrong to you?
I don't think so, because the generic interface version, there's two routes it can go. There can either be a create unsafe, create native, whatever you want to call it, API that takes a t integer, where t integer is sub of I binary integer, and therefore it supports things like int 128, big integer, etc. Or you have an explicit method that is convert to int 128, and it uses the I binary floating point properties for mantissa and exponent to determine whether or not it would overflow and therefore do the correct thing. So no matter which route we go, whether we have it itself generic at and take in a t integer, or we have them explicit int 32, int 64, and int 128, you can still do the right thing even in a dim. And so we're not going to box ourselves out of extensibility there at all.
So what I have on screen right now, does that kind of summarize our conundrum? Like, I don't have a huge problem with adding 6 or 8 methods to the generic type, but I am somewhat concerned that that might not be the end of it. Because I feel like the consistency argument usually comes with more types, and that might over time create a mess. That's my only concern.
Yeah, I think in this case, this is a consistency argument only in the context of the consistency is very well defined in what it would support, what it would extend to, etc. And the worst case scenario is effectively we look at the generic math stuff. We say we want a generic, and so we come back and we say that these ones should correspondingly be convert to integer of t integer, and we only have 2 APIs on each type.
Yeah, I mean, I think based off the extensibility to longer and shorter, I guess right now shorter, aka byte, isn't a problem. But if we ever decide that we want to go back to supporting running on 16-bit systems, then it may become a thing. If we're doing it for generic reasons, then I wonder if we do want the platform native type statics for the people who want to use it using defined types, and then we do something just with generics for the generic types. And let that manifest. That
I don't think we want to start living in a world where something is only available to the generic math and not available to the standard types themselves.
it would be available to the standard types themselves, just with a different calling pattern.
Right, and that just leads to we're defining an API on the type and not exposing it, but exposing it indirectly elsewhere just for people who want to still use it. Just expose the type in the right place in the first place. Don't make people jump through hoops.
I mean, we could have the double dot convert to binary integer of tintiger. Just that would look annoying and no one would use it, and then they'd call platform native dot double to int32.
Right, which is making people jump through hoops for no reason. That's my point. We're effectively saying like an API has to live on this type, but we want to hide it and make people jump through this hoop to access the data anyways.
Right, but it comes back to the both up and down. Like you say right now, int32 is all we need. That's because 32-bit is the minimum platform we support. If we have a reason that we feel that .NET needs to start supporting 16-bit platforms again,
then .NET cannot support 16-bit platforms because of how the runtime spec defines size of int pointer, alignment requirements, and everything else. It's not going to happen.
I mean, it used to support Win16, so there's.
It didn't really support Win16.
Fair enough, but you know, as we get bigger, we may need more things for the biggers because, like, oh well, why does the bigger have to go through the generic dispatch when the other thing? Like, this is where it's the like. We need to decide what the problem is and how we want to solve it. And like, I like keeping the types that everyone needs to use, like double, feeling somewhat, you know, sensible. And I think that adding only the converts that have a ambiguous platform interpretation, like that's the notion of sensible starts going out the window.
I mean, that's also what other platforms like WASM and Rust are already doing, because that's what makes sense in the context of these types in IEEE.
That's what I'm just like, this is where my feeling of unease on this is coming from. But
I mean, my question is also like, can we provide a generic helper that handles all the cases rather than exposing it through a generic interface?
We could, so I don't think we could reliably do it and make it efficient through just a external generic method. I think we could cut these down to just convert to integer and convert to integer native or convert to integer unsafe and make it take a t integer where t integer is sub of I binary integer.
So then if we do that, I mean, we could have literally a dedicated type where this would live as a method, right?
No, we couldn't make it fast.
It needs to be declared on the source type because only it knows how to do it. I think is the problem.
Yeah, we
only double knows how to convert a double.
We'd have to have potentially expensive type checks and run into other inlining and various other issues, and then you also end up with the general issue of I've gone and moved my types around and, you know, hidden and abstracted them so that they can't be found for something where the people who actually need this need it to be found and visible. And the perf regression is, you know, so the perf regression for an algorithm is about 20%. The perf regression for an individual cast is up to about 3.5 times.
Sure, but like, if we think we can do this sensibly with convert to integer of tintiger and convert to integer native of tintiger, then that's what I would rather do.
So I'm not entirely sure what this means. It just means instead of exposing 8 methods on double, you get to expose 2. Is that what you're saying?
Yeah, it would,
because
it would
then
cut it down to 2.
To me, that satisfies the why it needs to be in generic math and why it needs to be, and that it is extensible, and we're not going to need to come back to it and revisit it over and over and over again. Like, if we think that that this is needed for generic math, and the ultimate description of it in generic math is in terms of a generic source and generic destination, then that's what we should just write.
So
if we need the pre-specialization of, well, while the JIT can figure out that the target was int, and so it can emit this thing in the people who have this as a fixed thing, it would be better if they had a single target method. Then we add the platform native static helpers on the side. That's my feeling. But I have to run because I told my wife this meeting would be over half an hour ago.
So before we go, let me just quickly sketch what you just said, and then we can apply this pattern elsewhere. Is that effectively it? Like this sample code here?
You'd return t integer, not int,
Sorry,
and
yeah.
you'd take double, and you'd constrain it to I binary integer rather than I number.
Well, you wouldn't take a double because that's going to be the I floating point number interface member, right?
Right, but it'd be implemented on double, and so therefore the one on double
but
would take double.
Right. Sorry, yes. It would take T self as the argument. Yeah.
So like this then?
Yeah. And then the corresponding bit that would be on the interface would take T self rather than double. And
Yeah, and then I would probably call the unsafe, I would call it platform.
I'd rather native than platform if we're not
Sure.
going to do unsafe.
Sure.
Yeah, either one works for me. Okay, then
yeah, so I think that's the pattern that seems more appropriate to the fully generic math concept.
And I think I'd call it convert to integer, not convert to tintiger.
Yeah, whatever.
Yeah.
So what would you call it? Convert to integer?
Convert to integer.
Yeah.
You don't need to include the generic type name in there. That's just
I agree.
confusing.
Spelling is optional.
Krill, to answer your question, it's not that it's unsafe in the sense of pointer arithmetic unsafe. It's that it's that the behavior is non-deterministic from platform to platform, and so the result you get on ARM versus x86 differs for some inputs. Native captures that as much as unsafe does.
Excuse me. Yeah,
So
I'm happier with the fully generic one.
So do we approve this, or do we say come back with the design that includes the generic math as well? I'm okay either one.
I mean, we've already designed what the generic math includes here, so I'd just be coming back to with it explicitly typed out, which is these same APIs on half and single, and then on I binary floating point.
Yeah, so I think if we rewrite this to say it's the interface I binary floating point, and then we change double to be T self value,
yeah,
then that's probably the answer, and then it's make all the types that conform to that interface conform to the interface.
Fair enough. So then be okay with approving it as is? That's what I'm hearing.
Mr. Tobe, you've been awfully quiet.
Yeah, I don't love it, but I don't have a better answer.
Okay.
That's how that goes. That's how Tanner gets it his way every single time. We just don't know what to do with it. All right, then that's it for today.
Before you, go ahead and hit. So you called the parameter double. It should be double value because it's on the generic interface. It's T self value.
Excuse me.
And then you should probably delete the original proposal because that's not what we approved.
I can do that. You don't like double?
I pasted it in, well, except for the namespace stuff.
Because the like double's fine when it's double, but when it goes on the generic interface, it'll be T self value.
Right. Yeah, I mean, using keywords as parameter names is generally a bad idea. So that was just a typo.
Mm-hmm.
All right, then that's it for today. And then happy Thanksgiving or Friendsgiving or whatever you do. And then I see you maybe next week, depending on whether we still have quorum. We might not, but
Next week, if we meet next week, it'll be my last week for the year.
yeah. There may be other people in this camp, I think, potentially. So we'll see. I'm optimistic.
I'll just take all the APIs that no one else wants to review and get them approved. I'll have to think of them first, though.
I was gonna say, yeah, me being out, I think is days that everybody tries to get their stuff reviewed on. So no one left. All right, I'll be there, Zane.
Sounds good.